This is Xenofeed, news of the outworld.
Imagine being able to read someone's mind and turn their thoughts into written words. This may sound like science fiction, but it is actually a scientific breakthrough achieved by researchers at the University of Texas at Austin. They have developed an artificial intelligence system that can translate a person's brain activity into a continuous stream of text without the need for invasive implants or predefined vocabulary. This system, called a semantic decoder, could potentially help people who are unable to speak due to various conditions such as stroke, brain injury, or motor neuron disease. The semantic decoder is based on two main components: a brain imaging technique and a language model. The brain imaging technique is functional magnetic resonance imaging, or fMRI, which measures the changes in blood flow in the brain that reflect neural activity. The language model is a type of artificial neural network that can learn the statistical patterns of natural language from large amounts of text data. The language model used in this study is GPT-1, a precursor to the more advanced models such as ChatGPT and Bard. The semantic decoder works by first training the language model to associate brain activity patterns with semantic representations of words and sentences. To do this, the researchers recruited 3 volunteers who listened to hours of podcasts while lying in an fMRI scanner. The podcasts covered a variety of topics such as science, history, and culture, and contained diverse vocabulary and complex sentences. The language model learned to map the fMRI signals to semantic meanings of the words and sentences in the podcasts, using a numerical representation called word embeddings. After the initial training phase, the semantic decoder was able to generate text from brain activity alone, without any prior knowledge of the content or context. The volunteers were asked to either listen to a new story or silently imagine telling a story while their brain activity was recorded by the fMRI scanner. The semantic decoder then used the language model to infer the most likely words and sentences that corresponded to the brain activity patterns, and produced a continuous stream of text as the output. The results were impressive, as the semantic decoder was able to capture the gist of the original words and sentences, and sometimes even reproduce them exactly. For example, when a volunteer listened to the sentence, "I don't have my driver's license yet," the semantic decoder generated the text, "She has not even started to learn to drive yet." When another volunteer imagined telling the sentence, "I don't know whether to scream, cry, or run away. Instead I said, leave me alone," the semantic decoder produced the text, "Started to scream and cry, and then she just said, I told you to leave me alone." The accuracy of the semantic decoder was about 50%, which is remarkable considering the challenges of decoding natural language from noisy and sluggish fMRI signals. The semantic decoder is a significant advancement in the field of brain-computer interfaces, as it demonstrates the possibility of non-invasive mind reading using artificial intelligence. The system could have various applications, such as enabling communications for people who are unable to speak, enhancing creativity and memory, and studying the neural basis of language and cognition. However, it should go without saying that the system also raises ethical and social issues such as privacy, consent, and responsibility that need to be addressed before it can be widely used.
This is Xenofeed. If you enjoyed this video, leave your comments below, and please remember to like, share, and subscribe.